Hello students, good morning to all of you. Am I audible?
Yes, ma'am.
Okay, yesterday we discussed about matching. Matching was set of independent edges, right? Then maximum matching, that is maximum cardinality matching, okay? And perfect matching. So can you tell me K5, can you find any perfect matching in K5? What do you understand by perfect matching?
No, ma'am.
Why not? Why not?
Because there are odd number of
Odd number of
vertices.
vertices. So if we need independent edges and perfect matching is the matching, which one? Tell me, which saturates all the vertices, or you can just say which contain all the vertices of the graph. But here we can have maximum matching that can have four vertices, that is two edges, right? So no matching can contain all the five vertices. And you can just say no matching can contain odd number of vertices. Okay. And we discuss about the perfect match, that is perfect matching in KNN. So this is 2n order graph. Okay. And vertices from here and vertices from here. How many perfect matching exist? N factorial, right? N factorial. Clear? And these n factorial matching, or you can just say one is xi, yi. Xi is coming from x partite set, and there is y partite set, there is yi. So if x1 is adjacent to y1, you are taking that. X2 is adjacent to y2, and so on. There are a number of edges will be there in perfect matching, right? Because total number of vertices is 2n. Clear? And this is your 1 1 on 2 mapping, okay, bijection. And how many bijection exist from n set, and that is n element set to n element set, that is n factorial. Okay, and these matchings you can also denote by permutation matrix. By permuting, first you can just find xi, yi, and then whenever you are having xi, yi, this is matching. That is m contains x1, y1, this edge x1, y1, x2, y2, x3, y3, and so on up to xn, yn. So, can you tell me the permutation matrix corresponding to this matching? Permutation matrix will be how much cross how much? Order of permutation matrix will be, yes, here you have xi, yi, right? Are you
N
getting it or
cross
not?
N.
This will be n cross n and x1 y1 related. So here you can just write x1 x2 and so on, y1 y2, right? So x1 y1 related, whenever any element is related, ith element is related to j, then mij will be 1, otherwise 0. X1 is not related to x2, x1 is not related to x, that is not x2, y2, y3, y4, and so on up to yn, right? Now, x2 is not related with y1, so 0. x2 is related with y2, so 1, and rest are zeros. Clear? How to find this matrix? Are you getting it? And then x3, here you have x3 is related to y3. So at 3, 3, it will be 1, other 0. Clear? And so on. Last one will be 1. Clear? This is your identity matrix of order n. Clear? And corresponding
Yes,
to
ma'am.
identity matrix, you have xi, yi, this matching. Okay, I is running from 1 to n. Okay, so this is one of permutation matrix. Identity is one example of permutation matrix. And what do you understand by permutation matrix? If you have in every column and row one, other zeros. Okay, clear? Now you can permute it. You can interchange the rows and columns, whatever you want, and you will be getting all the other permutation matrix. If you interchange this one with this one, then you are getting 0, 1, 0, 0, 0. Okay, and here 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, and rest is same as this one. So this matching shows that x2 is related with y1 and x1 is related with y2 and other are xi, yi. Clear? So this is also one of the permutation matrix. Got it? And for example, in this one also it is given matching KNN. Out of KNN, we have chosen only three. That is K33. We have chosen K33 is having how many edges? 9. 3 into 3. Right? Out of these, we have chosen 3 edges. Clear? This one, and this one. Corresponding to this one, matrix will be this one. How? 1 is related with 2. So M12 will be 1. Others are 0. 2 is related with 3. So 2, 3 will be 1, others are 0. And 3 is related with 1. So 3, 1 will be 1, others are 0. Okay, there. So like this, you can interchange these matrices and these matching. So if matrix is given, you can easily find the matching, which one is this. And if you are given the matching, all the edges of the matching, then you can find the permutation matrix. Okay, so this was all about K and N. Now, perfect matching in complete graph. In K1, K3, K5, K7 means to say whenever odd order any zone, there does not exist any perfect matching, right? Clear? So we can only talk about K to N. Okay, if perfect matching exists, what is the cardinality of matching? We have 2n number of vertices. What will be the cardinality of that matching if perfect matching exists? Yes,
I'm 2N.
cardinality of matching. Matching contains edges, and one edge is associated with two vertices, and no vertex is common between any two edges. Okay, between any two or three edges, no vertex is common. Now tell me, these two n vertices are occupied by can be occupied by n edges, na? So it will be n,
And
not two. Okay, and how to find that? You can just K2n has two n vertices v1, v2, and so on up to v2n. We have taken it. Okay, and cardinality of m will be n. Maximum matching as well as minimum matching. Okay, in case of even order graph, uh, if perfect matching, every perfect matching will be maximum matching. Clear? Yeah. Here you have v1, v1, v2, v2, and 2n number of vertices. So v1 can be connected to. You can choose any edges. Here, every two vertices are adjacent because it is the complete graph. Clear? So you can choose any. You are free to choose any edge. So if you choose v1, v2, then these are fixed. Then you can choose v3 to any other vertex, right? Means common vertex will not be there for perfect matching. Clear? So V1 has, you can choose V1 to V2, V1 to V3, or V1 to V4, or V1 to V2N, like this. So how many choices for V1?
2n minus 1.
2n minus 1 number of choices are there for V1. Now we have chosen, suppose V1 to Vi we have chosen. Okay, or Vi plus 1 you can just say. V1 to Vi plus 1 we have chosen. So one vertex this gone and one vertex this gone. Okay, two vertices are gone. You can take Vi, doesn't matter. Two vertices are gone, right? This one. Then V2. How many vertices are left for V2? V2 can map to, that is, we can choose which edge from V2 to 1 gone, 2n minus 1, 2n minus 3, and itself, right? 2n minus 1, 2, and 3. Clear? Three
Yes,
vertices
ma'am.
को छोड़कर how many 2n minus 3 we can choose. So there are for V2 how many choices? 2n minus 3 choices. Like this, four vertices are gone. Suppose Vi plus 1. Vi plus 1 we have chosen. So V2 and Vi plus 1 also gone. Now for V3, how many? Four these and one these gone. How
2n
many
minus 5.
remaining? 2n minus 5. Clear? So for V1, 2n minus 1. For V2, second vertex, it is 2n minus 3 choices. And for third vertex, there are 2n minus 5 choices. Clear? And so on up to Vn, the last vertex, you will be remaining only one choice. Okay? Clear? So like this, how many perfect matching exist? This into this, and so on. So okay. So for K2n, there are 2n minus 1, 2n minus 3, 2n minus 5, and so on 5, 3, 1. Clear? Got it? Whatever the 2n, whatever the order, this one, minus 1 into 2n minus 3 into 2n minus 5, and you will be keep subtracting this one until you are getting 1. Okay, for example, for K4, how many perfect matching exist? We have already shown that how many perfect matching exist. These two edges you can take it, and another is you can take these two edges. Okay, and another is you can
Isolated.
not isolated vertex edges na for perfect matching. So these two, right? Means independent edges you can just have. So for K4, three number of perfect matching exists. We have already shown, right? These two edges making one perfect matching. For second one, you can take these two edges. For third one, these two edges. And why these are perfect? These are containing all the vertices. That's why perfect matching. So corresponding to K4 by using this formula, how many you got it? 2n minus 1. So that is 2n is what? 4. Okay. So 4 minus 1. 2n minus 3. 4 minus 3. You stop here. Why you stop here? You are getting 1 over here, right? So 3 into 1. Are you getting 3? Yes. So like this, for K6 and K8, tell me, how many perfect matching exist for K6 and K8? Yes. How many perfect matching? According to this formula, you can just calculate it and tell me.
on 15 and 100.
15 and
100.
105. Is it? So,
Yes,
in
ma'am.
general, total number of perfect matching for K2N is given by this one, I already told you. For this one, it is. For K4, it is 3. For K6, it is 15. For K8 will be 7, that is 8 minus 1, into 8 minus 3, into 8 minus 5, into 8 minus 7, that is this one. So, 105, I think. Yeah.
Yes, ma'am.
Any doubt for KNN, perfect matching for KNN, K2N? If no, maximum matching. Maximum matching, its name suggests that maximum cardinality. Something should be maximum, right? And in case of matching, we have the cardinality only, right? Number of edges. So matching with maximum size, and here size means cardinality. Okay, is known as maximum matching. Okay, and this is denoted by alpha dash g. Okay, alpha dash g. That is, what is this alpha dash g? Yes.
Maximum size of matching.
No, in graph, what it denote? How many independent edges? Maximum number of, right? How many maximum number of independent edges are present in any graph? That is your alpha dash g. Independent number of edges. Okay, alpha dash g. And what will be alpha g? This will come, I think, in 3.3 or in this section only. That will be your maximum independent vertices. Okay, that's why this is alpha dash g. Alpha g is your maximum independent vertex cardinality. Okay, the total number of maximum is no, maximum number of independent vertices, and that we have done while doing the clique and independent set, right? So maximum independent set we have found in chapter 1. Okay, so maximum cardinality is given by alpha g, denoted by alpha g, and maximum cardinality for edges is denoted by alpha dash g. Clear? So there is one this word maximum and another is maximal. What do you understand by these two words? Yes, you have used many times maximality, right? Tell me, maximal. Anything which is not the which cannot be extendable, which is not contained properly in any other, right? So that is the meaning of maximal. And maximum is corresponding to the greatest cardinality, greatest size, greatest order, something that is associated with largest, greatest, right? So maximal is uh, a matching m such that which is not extendable, means to say is that there does not exist any other matching which is properly containing m. Okay, so a matching which is not properly contained in any other matching, this AM is then known as maximal matching. Any maximal matching may not be maximum. Okay, for example, you can just take the example of this P4. In this one, what do you understand by yeah? What is the cardinality of maximum matching over here? Maximum matching. What is the cardinality of maximum matching? Four vertices are there, na? If exists, maximum matching will be having cardinality 4 by 2, right? Two vertices associated with each edge, and the cardinality of that will be E1, E3, right? So this is your maximum matching as well as maximal. Every maximum will be maximal, but maximal may not be maximum. Clear? What about E2? The matching with E2. Is it maximum? Is it maximum? Yes. Is it maximum? Tell me. See, E1 is also matching, E3 is also matching, E2 taken at a, that is any matching, any set with one cardinality that is also matching. E1 is not the maximal because this is contained in this E1 with that is M1. E3 is also contained in M1. So these are not maximal. What about E2? Maximal? Yes. Avoidable? E2. क्या प्रॉब्लम कहाँ है? Why are you not responding? Aren't you getting the definition difference between maximum and maximal? Am I audible?
Yes, ma'am.
Tell me E2. E2 is maximum or maximal or nothing.
Maximal.
Maximal, not maximum. Maximum is we got one matching with cardinality two ना, so two से नीचे वाली maximum हो ही नहीं सकती है, right? But maximal हो सकती है. For example, E2 you can just take, and E2 cannot be extendable, right? E2 is not contained in this one, and not in that matching, not in that matching. So this will be maximal but not maximum, and every maximum will be maximal. This implies this one but not the reverse part. Okay,
Yes, ma'am.
every maximum matching is maximal. I already, yeah. Now you have a path. Yeah. Before that, in this graph P3 and P5, P4 we have discussed. P5, can you find the cardinality of maximal and maximum matching? Maximum matching cardinality is alpha dash, right? So tell me alpha dash for this one. For P2 it was 2. For P2 alpha dash, sorry, P4 it was 2. Alpha dash of P4. So alpha dash of P3 tell me, and alpha dash of P4 tell me. Yes, tell me. Yes, what is maximum matching cardinality in P3 and P5, not P4? This is your P5. Hmm?
2.
P3 0.
P3 0. How?
No, ma'am, 1.
1.
No, ma'am, 1 1. Yes.
And P5, one matching at a time, and both are maximum. You can take this as or this as, right, at a time. And both as if you take it, that is not at all matching. And here, you can take this one, you can skip this, you can take this, right? Similarly, you take these. Okay? 2.
2.
So in general, alpha dash of Pn. Tell me. For P3 it is 1, for P4 it is 2, for P5 it is 2, for P6 it will be 3, for P6 it will be 3, for P7 again 3. Tell me how many
Lower value of
next
n. Lower function of n by 2.
lower function of n by 2. For P1 it is 0. Okay, so that is the maximum matching cardinality, or you can just say the maximum number of independent edges present in that graph. Clear? Matching tells that only maximum, and that is independent edges. Matching consists of independent edges. Now, M is the matching given on M alternating path. What do you understand by M alternating path? Any path for a given matching M. An M alternating path will be any path that alternates between the edges in M. Okay. For example, if you are given M1 is the matching, this one in this graph, this is the matching. Okay. This is your matching. Okay. And any M alternate path, or you can just say M1 alternate path, will be a path which alternates between the edges of this. So this one is the path. That is, here you have edge, that is matching edge. Here you don't have matching edge. Again matching, no, then yes, right? So alternatively, you have one edge from the matching and one edge outside the matching. So that path is your M alternating or M1 alternating path. Clear? Got it? Can you find M1 for this one only? Any M alternating path containing E2. Containing E2. Yes? Yes? Tell me. Any path, any M alternating path containing E2 as well as E5. So containing E2, you can take E1, E2, E3, right? This will be your M alternating path. This path alternates between the edges of M, right? This one edges from M, not from M. Edges from M. Okay? But what about this path? E2, E5, E6. Is it M alternate path? You have only this one coming from matching. Yes, edges of the path are alternative to edges of M. No, right? You have continuously two edges, consecutive two edges that do not have any edge from the M, right? So any path that alternates between the edges of M, that is known as an alternating path. Okay, and edge is not in M. Okay, and next one is M augmenting path. M augmenting path will be this path only. This type M alternating will be first. It should be M alternating path whose endpoints are saturated by M. Okay, whose endpoints are saturated by M. That means whose endpoints contained in M. Okay, for example, if I just take this one, here every vertex is contained. So yeah, in this graph, this is your M given, matching given E2 and E4. Okay, now this path E1, E2, E3, E4, E5. This path is M augmenting or not? These are endpoints should be M unsaturated. That means what did I say? Contained in M. No, it should not be contained in M. Actually, this is your M unsaturated. So this is your what? Not contained in M, and this point is also not contained in M. Okay, that's why this is your M augmenting path. So whatever this path, if you take E2, E3, E4, this one, this is M alternating, but not M augmenting. Okay, because the endpoints are saturated by M. We want this should not be contained in M, but these are incident with the edges of M. Clear? Got it? Now, can you find any path in this graph, any path which is any M alternating path that is your M augmenting path? Can you find it? Can you find any M augmented path in this one, in this graph? And M is given as E1, E3, E6. And that will this path will be depending on the matching. Clear? That does not exist now because every vertex is contained in M1, right? So that does not exist any M1 augmenting path. Clear? We want what do we want for M augmenting? The endpoints of the path should be unsaturated by M. That should not be present in M. Clear? So this path, you can just say this one, E7, E3, E2. Is it M alternating? Is this path M alternating? M is given as E2, E4. These edges. Is it M alternating? E7, E3, E6. A path starting with this vertex and set this vertex. Is it M alternating? Is it M alternating? Hello, am I audible? Sorry, what's up, sir? Hmm?
No, ma'am.
Then is it M alternating?
Yes, ma'am.
Yes, ma'am.
Okay. So tell me the edge of M. MR E2 and E3 ना अल्टरनेट कहाँ से हो रहा है? E7 outside from M, E3 outside from M, E6 outside from M. M alternating कैसे होता है? One is either it should be अगर outside है तो second value inside होनी चाहिए. Next outside, next inside, next outside, next inside, right? That is your M alternating. That is one by alternate edges are coming from M. Okay, but this is not the case in this one. So this path is not M alternating. So this is not M augmenting. Clear? Got it? Then we have one more definition for symmetric difference. Symmetric difference. The difference just any two sets or any two sets A and B you represent by A minus B or A minus B, right? All those points which are present in A but not present in B. That is your difference. Okay. But if you take all those points which are present in A but not present in B, union with all those points which are present in B only, not present in A, that will be your symmetric difference. Got it? And just apply on the graph. Same thing. Clear?